Morning students, today we will do the exercise of Euclid geometry. Euclid geometry, you got axioms, you got postulates, 7 axioms and 5 postulates, and then I have seen through 1 point we can draw infinite number of lines, and through 2 points we can draw one and only one lines. Now let's see the exercise 5.1. Which of the following statements are true and which are false? Give reason for your answer. Only one line can pass through a single point. Is it possible? I have drawn already. Is it possible? This is a point, A is a point, and through A all these lines I have drawn. So whatever given in the statement, is it correct? It is not correct. So what is the correct one? That through a point we can draw infinite number of lines. So that means the first statement is false. Second, there are infinite number of lines passed through 2 distinct points. Is it possible? Is it possible? Whatever line you draw, ultimately it will be only one line overlapping one another. So through 2 distinct points we can draw one and only one line. So this is also false. Third one, a terminated line can be produced indefinitely on both the sides. A terminated line. So that means terminated line means what? Line. It is not a line segment, it is not a ray. So terminated line. This arrow indicates that this is a terminated line. This is not a terminated line. This is a line segment, but this is a terminated line, and this can be produced on either side of the point. Okay, so this is true. Fourth, if 2 circles are equal, then their radii are equal. Let's see. So suppose this is one circle and this is another circle. And if we say that these 2 circles are equal, 1 minute. Now, if we say that these 2 circles are equal, that means what? Their radii must be equal. Suppose you take 2 5-rupee coins, then what will happen? Each and every point of 1 5-rupee coin will meet each and every point of another 5-rupee coin. That means both the 5-rupee coins are equal. Now you may say, sir, all the 5-rupee coins, definitely it should be of same type. See, nowadays it will be one is a small, less thickness, and other is that old one. If you take 2 old one, it will match. If you take 2 new one, then also it will match. So ultimately, one thing you can see, that if 2 circles are equal, that means their radii will be also equal. So this is also correct, that is true. Then, fifth one. See, suppose if I say PQ equal to XY, XY equal to AB. PQ is a line segment, XY is a line segment, XY is a line segment, AB is a line segment. That means ultimately what is that? AB equal to PQ or PQ equal to AB. So again, what is given in the figure? AB equal to PQ, PQ equal to XY, then AB equal to XY. I have taken in another way, so you can take according to the book. So this is also correct. This is also true. Okay? Because suppose this is 5 centimeter, this is 5 centimeter, this is 5 centimeter, this is 5 centimeter. So ultimately PQ will be equal to AB. Or according to the book, it will be AB equal to PQ, then PQ equal to XY. So ultimately PQ is the common. Here you can see this is the common part. This is the common part. So ultimately AB equal to PQ. Clear? So this is true. Now next one. Give the definition of the following. Now, definition, you see parallel lines you got in lines and angles. Then perpendicular lines, if two lines meet at a point in such a way that they form 90-degree angle, then they are said to be perpendicular to one another. Part of a line is known as line segment. Suppose this is a line, and suppose we are taking this much, that is A, B, and if I rub this part, see there is no termination point is there. So this is a line segment, part of a line. Then radius of a circle. Radius of a circle means what? See, radius of a circle. So, suppose this is a center, P, Q, R, S, T. So, the line drawn from center to any point on the circumference of a circle, line drawn from center to any point on the circumference, all the points P, Q, R, S, T, all are on the circumference of a circle. So that means these all are radii. Okay, this is known as radius. So what is radius? The distance from center to any point on the circumference is known as radius of the circle. And then square. Square is what? That square, a polygon bounded by four sides, whose all sides are equal and all angles are right angles, and all angles are right angles, is known as a square. A polygon bounded by four sides, and all the sides are equal and all the angles are right angle, then that polygon is known as square. Okay. Now next they are asking, are there other terms that need to be defined first? What are they? So here you can see they have written square. But before square, first we have to study quadrilateral. Before equilateral triangle, right angle triangle, equiangle triangle, first you have to know triangle in general. So similarly, first supposed to be quadrilateral, supposed to be defined. Quadrilateral not defined. So what is a quadrilateral? A polygon bounded by four sides is known as quadrilateral. A polygon bounded by four sides is known as quadrilateral. The next, here you see whenever we are drawing, suppose here you see two radii form an angle, two sides form an angle. So angle is not defined. So angle you have to know because already you got, and that is why it is not given here. Okay. So these are the points you have to know. Now next, given question number 3, consider two postulates given below. Given any two distinct points A and B, there exists a third point C which is in between A and B. And next one, there exist at least 3 points that are not on the same line. See, suppose this is a line. This is AB. This is C. And suppose this is another P, Q, and this is R. The R is not on PQ. R is not on PQ. So here C lies between A and B. Here R is not on PQ. What they are asking, does this postulate contain any undefined terms? Yes. In Euclid, if you see, they did not discuss about the collinear points. They did not discuss that point which is not lie on a line. That did not discuss. So that is, but still there is a one, the exam 5.1, if you see, they define that through 2 points we can draw one and only one line. So if I consider A and B are the 2 points, whether C is a point or not, that is not the question, because through AB we can draw one and only one line. Okay? But these are the things not discussed in the Euclid geometry. One, that collinear points, another is non-collinear points. Coincident point and coincident point, that means points which lie on the same line. Okay? And then that non-collinear points, well, the points, if 3 or more points does not lie on a line, are known as non-collinear points. So these are the things not discussed in the Euclid geometry. And now next one, if a point C lies between A and B such that AC equal to BC, prove that AC equal to half AB. AC equal to half AB. Now let's see. So only diagram is drawn, so work is less. Now here what is given, actually here they have given C is a midpoint. C is a midpoint. What is given? If a point C between 2 points A and B such that AC equal to BC. So AB is the line. It is given that AC equal to BC. Okay? Now this is equation number 1. This is equation number 1. Next, you see AB equal to what we can write? AB equal to, we can write AC plus BC. Then what we can write? AB equal to AC plus AC using 1 implies AB equal to twice AC implies AC equal to half AB. This is the question number 4. This is question number 4, exercise 5.1. So much time I did not write so that you can find out which exercise I am doing. So this is exercise 5.1, question number 4. This is the solution. Once again, just I will explain. AB is a line, C is a point, lie on AB such that AC equal to BC given. Now this is equation number 1, or that is a given condition. Then what we can write? AB equal to AC plus BC. So AB equal to AC plus AC because BC replaced by AC using 1. Then AB equal to twice AC implies AC equal to half AB. This is the solution of the question number 4. Now next, question number 5. In question number 4, C is called a midpoint of a line segment AB. Prove that every line segment has one and only one line segment. One and only one line segment. Okay. So same diagram. Question number 5. AB is a line. C is the midpoint of AB. C is the midpoint of AB. So that means AC equal to BC. Equation number 1. To prove C is the only midpoint of AB. C is the only midpoint of AB. Then now C is the only midpoint of AB. How can you prove it? We cannot prove it only by this. So we will consider that D is another midpoint. Now proof. See, let assume D is another midpoint of AB. Assume D is another midpoint of AB. As you can see, I have taken. Now, if D is the midpoint, then what will happen? Then definitely AD equal to DB. Now, then you see AD is what? AD equal to AC plus CD. AC plus CD. And DB, what we can write? DB you can write BC minus CD. Yes or not? BC minus CD. BC minus CD we have written. Then you can see one thing. Here already we have written AC equal to BC. So write BC plus CD equal to BC minus CD. That means what? BC cancel. CD plus CD equal to 0. Implies twice CD equal to 0. Implies CD equal to 0. That means if D is the midpoint, then CD is supposed to exist. But here CD is not exist. CD is 0. That means C is the only midpoint of AB. C is the only midpoint of AB. Because already we have used whatever given, AC and BC are only midpoint. So AC A part equal to BC part. So we have cancelled, then CD plus CD, twice CD, ultimately CD equal to 0. That means CD does not exist at all. So if CD is not exist, that means D does not exist. So ultimately what is that? C is the only midpoint of AB. C is the only midpoint of AB. So this is the solution of question number 5. This is the solution of question number 5. Now let's see next one. Let's see. See AC equal to BD and prove that AB equal to CD. Almost same type. The diagram is already given. So we can draw the diagram again. Okay. So let's draw the diagram. Question number 6. With this I will wind up for today. Because question number 6 I'll do, 7 I'll do next day with little more explanation of that question number, which one? That postulate 5, and then we will do. Okay, so this is question number 6. Question number 6. So question number 6, you can see one thing, that it is given A, B, then this is D, this is D, this is C. And what is given? They have given that AC equal to BD, AC equal to BD, given. This part is given, there is nothing to write extra, already given. Now what we can do, see one thing, AC can be written as AD plus DC, and BD can be written as DC plus BC. Then DC is common, so AD equal to BC. AD equal to BC. AD equal to BC. So this is one part can be. This is one part. One way we can prove that AD equal to BC. But in the question it is given AB equal to. Okay, I have taken different question. Okay, I have drawn the different diagram. So let me explain once again. So this is also one. You can write it down. Actually, I have just changed the location of the point, and that's the reason, nothing else. I just change the location of the point. So see, location of the point A, B, C, D. A, B, this is A, this is B, this is B, this is C, and this is D. What is given? Given is that AC equal to BD. AC equal to BD. So ultimately, AC equal to what? AB plus BC, then BC plus, but you have to prove CD plus CD. So same thing only. Okay? BC common. So AB equal to CD. So this is the proof. This one, if we change the point, then this is the answer. If according to the book, then this is the answer. Okay? So with that, we'll wind up for today. Hope to see you in the next class. But this is very easy. You have to learn by heart the postulate. You have to learn by heart the axioms, because sometimes in the exam they used to ask that write down 3 axioms, or they will ask you that whole is greater than a part. Indicates which axiom. You have to write down the axiom number. So those things you have to remember, and so then this chapter is easy, not much tough. Okay. With this, I'll wind up for today. Then practice, and then you can get a good marks. Okay. Thank you. Have a nice day.